Good morning. Welcome. My name is Zubin. I help lead marketing for NGINX. I hope to spend just a few minutes this morning giving you a quick overview of what's new with the NGINX portfolio, and then handing it over to my colleagues to talk about edge security, multi-cloud networking, and scaling and securing Kubernetes deployments. NGINX was created to solve a very fundamental challenge in computer science, which is concurrency and handling traffic at scale. And to give a quick recap of where we've come from, the original open source NGINX was created in 2004 as a lightweight, high-performance web server, proxy, and load balancer. And the architecture for NGINX was created to solve for high volume, high traffic concurrency. Just fast forward a few years and internet scale companies like Netflix and MySpace and Box and Dropbox were all using NGINX for ingress into their applications. What we discovered at the time was that they're not only using NGINX to deliver those web applications, but they were also using NGINX as a way to route traffic between distributed services using RESTful APIs within the application. And that was a revelation for us at the time. And we realized that there's something here in terms of being able to scale up, a little open source project into something that would be enterprise ready. Fast forward a few years, we built a business around NGINX open source and accelerated the number of products that were available to help drive high performance web applications. So about 2013-ish is when we started to see dramatic adoption of NGINX open source to drive high performance web applications. About 35% of the top 1,000 websites in the world were powered by NGINX at the time. That's also when we released NGINX Plus. Over the years, we added more products, and for both the data plane as well as the control plane. I'll talk about that in a few minutes. And in 2019, we were acquired by F5, and we've been accelerating the capabilities of both NGINX open source as well as the entire NGINX portfolio. In May of 2021, we hit a huge milestone. NGINX is now the most popular web server in the world, overtaking Apache in May. And if you look at overall across all web technologies, NGINX and NGINX derived technologies, because NGINX is open source, run over 52% of all websites on the internet. 73% of the top 1,000 websites in the world are powered by NGINX today. So incredibly wide adoption of NGINX open source to be able to drive high performance web scale applications. And what we've seen over the years is that NGINX has grown from just being at one point in application infrastructure to being present in distributed app architectures, microservices, and now service mesh. There are really two aspects to the NGINX portfolio. One is what we call the data plane, and the other is the control plane. The data plane is where traffic is routed and secured into an application as well as within the services in an application. So let's say, for example, let's take this ride-hailing app that you see in the left of the slide. And this is a very simple ride-hailing app where each of the services each of the functions that constitute the app are broken up into services. The little NGINX hex on each of the services is a representation of, you could have NGINX at each microservice with very different, with a very different purpose. So NGINX is a little bit of a Swiss Army knife. And
sorry to interrupt. I have a couple of questions.
Yes.
So one is about the previous slide, because you said that you overtaken Apache as the most common web server in the internet. Okay, you mentioned performance as the first point. I mean, is it only that, or is there anything else that people like about your product? And if so, is there a difference between enterprises, large organizations, large websites, and smaller organizations from this point of view?
Yes, several. So, performance, of course, is incredibly important. The architecture of NGINX allows it to scale really well for concurrent sessions. So if you have a website that is incredibly popular, or a web application that's incredibly popular, you can easily scale up from a few hundred visitors to a few hundred million visitors using NGINX. And that has helped with NGINX's popularity. The second is NGINX is very easy to be configured and incredibly reliable. So it stays up, it's always on, you can reload configurations without taking down the website. So all of that has helped with that. Performance and reliability have helped with just being able to drive more adoption for NGINX open source. The one thing I do want to mention is, over the years, because of our investments in NGINX open source, we've also helped, drive new technology innovations and new standards, right? From HTTP 2 to what's coming up soon with HTTP 3 and Quick. So a lot of web standards are supported by NGINX, and if you need an application to be on the cutting edge of web standards, then NGINX is also a really good choice.
I have a follow-up question to this, and it might come up later in the presentation, but performance is really important, clearly, but to me, almost more important would be security. So do you, since as a web server, the prime target for any attacker, do you have any comparison how NGINX compares to Apache in terms of CVEs, vulnerabilities, and all that? I know an important factor is how to configure it, and Apache definitely sometimes gets tricky to configure it in a secure way. So how do you position yourself compared to Apache in terms of security?
Just like any other piece of software, right? We also have had our share of CVEs. I think that there are two things that we keep in mind when it comes to security for the basic NGINX open source, which is a very simple configuration with most tricky pieces of the configuration turned off by default, right? So that definitely helps. The second is that we have security capabilities that can be plugged into NGINX. So for the commercial and enterprise offerings, we have something called NGINX App Protect, which is a web application firewall that is a module that plugs into NGINX and then helps secure every single instance of NGINX. Because NGINX is open source, you can also use open source firewalls out there as modules. So in terms of security, the NGINX open source has had very few medium or high scored issues in the past.
Yeah, and I think maybe just Zubin, to pile on that too. What we do is when there is a CVE announced, we do act to shore it up and make that available both to the open source community as well as the licensed version. So we're protecting the core component as well, and we work with the community quite actively. And F5 as a company has also been very active in how we respond to CVEs. So we've had to deal with them, and we've had to deal with significant ones. And that's the world we live in today. And so we do have a disclosure process in place. We do have a security incident response team that's available 24/7 to work with these, whether they're embargoed or whether they're announced and the information is publicly available. So we do want to make sure that we address that across all of our platforms. And then, as Zubin said, at the application layer, which we're going to get into a little bit later, is certainly relevant too, and how the applications themselves are protected, because a website is an implementation of something. So all of that system needs to be thought through and protected, not just the core component. And so we want to make sure that that's available too, as well as making those things easily accessible, and regular signature updates and regular updates to the code, even just to address new concerns as they come around.
So coming back to the typical microservices application and the various use cases for NGINX. So NGINX could be just a simple layer 7 load balancer within the app. As mentioned earlier, around a web application firewall, you could also have a firewall at the application layer, but also with, you could have security capabilities within the app itself at the service layer to secure and route API traffic. NGINX also acts as an API gateway to be able to route all that API traffic between services. Increasingly, as applications are getting containerized, NGINX can act as an ingress controller into a Kubernetes cluster. And there are both open source and commercial variants of ingress controllers available. And lastly, because of the complexity around microservices applications today, service meshes have started to become increasingly popular as a method in which to organize and manage a microservices application. NGINX does have a service mesh, a free open service mesh product available as well, that is built on the core NGINX technologies. At the end of the day, the data plane that is powered by NGINX open source and NGINX Plus helps developers route and secure traffic within the app as well as traffic into the application. But to manage all of that at scale, what happens when you have 20 or 30 NGINX instances with different services? What happens if you have hundreds of NGINX instances managing different services in different data centers in different clouds? That's when a control plane or a management layer becomes incredibly important. And NGINX Controller is the control plane product that is now available that helps automate and simplify the operation of NGINX at scale. So what NGINX Controller is a very opinionated set of workflows that help you basically manage policies and how you deploy NGINX across instances in your application. So let me quickly show you what what enterprises have to deal with today. If you think of the left as a developer that writes code who then needs to deploy that code in an application that eventually leads to a customer consuming that app. There's a lot of different hops on the way. The environment could consist of microservices applications, monolithic applications. There could be a web server involved. RP is a reverse proxy. So you'd have a reverse proxy that's driving traffic into the app. You could also have a microservices app with a service with a sidecar proxy. And if the modern application is running in Kubernetes, you also need ingress control. And then that's just at the origin server. To get that traffic all the way from the origin, into the hands of a customer, you need layer 4 load balancing, perhaps API gateways, layer 7, firewalls, DDoS protection, global server load balancing and DNS, and then you need a content delivery network to help scale all of that across the globe at high performance. So what enterprises are dealing with today is having to engineer and configure a very vast set of tools that just becomes incredibly complex to manage because they don't necessarily all share the same architecture or the same configuration language or the same kind of interoperability. Our vision is to help simplify all of that using the NGINX suite of products, where NGINX Plus as a single, web server, reverse proxy, layer 7 load balancer, API gateway, or WAF can be used at multiple stages of the application. So the application architecture doesn't necessarily have to change, but it becomes a lot easier for DevOps teams, developers, and platform operations teams to be able to manage, deploy, and maintain the application at scale. And as you get closer to sending traffic over to customers, F5 Big IP can help with additional load balancing. And then we have edge capabilities and edge security with Shape and Volterra that help secure that traffic at the edge. We've also seen homegrown content delivery networks built via NGINX technologies, where large enterprises can just build their own CDNs. I did want to just mention that our premier event, NGINX Sprint, is coming up in August. NGINX Sprint is going to be where we're going to be making a few announcements around NGINX open source, some of our open source alliance partners, as well as giving folks a preview of our vision for where we think the NGINX product portfolio needs to be headed in the near term and the long term. So I hope to see you all there.
Hey, Zubin, does that NGINX support like multi-tenancy kinds of things? I mean, a lot of MSPs seem to use NGINX, and like web server uses NGINX and that sort of stuff. Is there intrinsic support in there for multiple tenants kind of environment?
Yes, but with caveats. So absolutely, but it really depends on the architecture and how it's set up. But yes, absolutely. But that's one of the reasons why, for example, you would see typical hosting providers, right, have shared instances of NGINX running, driving different applications.